Nick Bird. I work at KWS UK and we are seed producers for the agricultural industry. I work in the sort of science team, mostly on wheat. In fact, always on wheat. And sometimes I get dragged into other things and I don't particularly like that, so I stick with wheat. So I'm going to tell you a little bit about wheat and how it's driven human civilization, and a few fun facts, hopefully, about wheat. Now, we've got a quiz running over the KWS stand, and it's amazing the amount of people who don't actually know what wheat looks like. So just to give it away, this is what it looks like. So what has wheat done for civilization over the years? Well, before we do that, we have to start with a history of wheat a little bit. And wheat is a complicated beast. And I don't know why I picked to work on it, because it just makes my life even more complicated. But wheat is an amalgamation of 3 different grasses. And this happened many, many, many years ago. So we have this thing that looks a bit like a sort of barley or rye that's called einkorn wheat. And this is giving wheat the A genome. And then we have something else that looks like almost nothing you've ever seen before in your life. And this is a Triticum speltoides, another wild grass, that then about 150,000 years ago joined together with einkorn wheat and became durum wheat. Now, durum wheat makes pasta. Very important. Now, obviously, wheat in itself wasn't particularly happy at that point, so decided, accidentally, to grab another genome with also something that doesn't look like anything that anyone would ever grow for any grain or things. But actually, people do. Around the world, these are still cultivated for grain. But once these 3 genomes ended up together, we ended up looking like our modern hexaploid bred wheat. And this is what I work on. I don't try and work on these if I can help it, but sometimes it happens. So once this wheat got together, there was a huge amount of DNA floating around from these wheat plants. So let's talk about how much wheat DNA is actually around in its genome. So to help a little bit, I'm not sure it really does, we've got the solar system here, and each planet is represented by a genome size. So we've got some really smallish genomes here. A nematode at 100 megabases, chicken and zebrafish at around about 120. Then we move into some slightly different sizes. So we've got maize, so sweet corn, at 290 megabases, or 2,290 megabases, I should say. The human genome, which is very similar size to maize. We've got fruit fly. Loads of people work on fruit fly, probably because it's got a really small genome. It's really easy. We've got rice. A lot of people work on rice. And sea anemone, same genome size as rice, but they look completely different to each other. But there's one missing on here. In fact, there's a few missing. Arabidopsis, the most studied plant in the world. Also the most useless plant in the world, but this will never feed the world, I promise you. Okay, but some crops that do feed the world. We've got oilseed rape at 1,130 megabases, potatoes, 844, barley at 5,100. Now, this is closer to the genome that I work on. And here we go. Oh. Wheat sits at almost 16,000 megabases. So if you come and do your DNA extraction later, you'll see some strawberry DNA, which is kind of rice, sea anemone kind of size. And if you take that molecule of DNA and put it into a linear, it's about 30 centimeters long from one cell. If you do the same with wheat, it will stretch 10 meters. And that is on every single cell of wheat, 10 meters long. And if you think how many cells are actually in wheat and put it all in one line, it's something like 15,000 times from the Earth and round the sun from one plant. So we're working with a lot of DNA. There's only 200,000 genes in wheat, there or thereabouts. And it doesn't need all that, so most of it is packing DNA. But that genome has allowed wheat to travel around the world and adapt itself via that genome to grow in every continent on the world except for Antarctica. And it'd probably grow there, but no one's bothered planting it. So these green countries here, so India, Pakistan, Iran kind of area, that is where the wheat naturally formed. And then human civilization has moved it into every other purple country that you can see on here, and state in the US, because they couldn't deal with just one country. And all of that is in its DNA, and that's where it's moved, just because of its genome. So let's talk about yield and how that has changed the way that we have managed to keep our population as we are. So yields of wheat in tons per hectare, so massive bags per unit area, in 1200 to sort of 1600 were very stable at almost nothing. And it was a lot of work to get all of the wheat off the ground because it just didn't stand very well, etc. Then there was slight intensification in the 16, 17, 1800s where yields started to increase. And that was when farmers were actually keeping the best plants that they saw in their fields, and then they would grow those, and then they would keep the best of that field again and again and again. Now, in the 1900s, there's a massive spike, and that's down to almost just 2 genes and they were discovered in the Green Revolution. And I'll show you what the Green Revolution did. So in the 1200s up to the early 1900s, this was how tall wheat was. So about 1.7, 1.8 meters high. I have harvested stuff that's been 2.5 meters high. It doesn't stand very well when it gets that tall. It likes to fall over. But as you can see in the background here, in the background behind my daughter, this is more the height of wheat at the moment. So sitting around 70, 80 centimeters. And that drop in height has meant that all of those wheat plants don't now need to put its energy into making tall plants. It can put it into the grain. And therefore we can get more grain per plant based on just a reduction in height. And those 2 genes are called RHT1 and RHT2. So reduction in height, 1 and 2. And that has driven that yield gain, just like that, just in those 2 genes. And what has that really meant? Well, this happened in the 1950s, mid-1950s, 1960s. So this is a sort of blow-up of that high curve that we see. And here you can see that whilst population has increased immensely, cereal yield and production has also kept pace, if not higher than our population. But actually, the land used has been pretty stable all that time. So we're not using any more land in terms of producing cereals, but we're still feeding the population because our yields have increased. A lot of it is down to those 2 genes. Obviously, there are more things thrown on top, but we owe a lot to those 2 genes. Okay, so whilst wheat has decided or helped to feed the world, it's also had a few blips on the way. And one of those is, I don't know if any of you heard of the Salem witch trials. So in 1692, 200 people in Massachusetts were accused of witchcraft. Of those 200, fortunately, only 31 were found guilty. 19 were hung once they were found guilty. 1 was pressed to death. Squashed because he wouldn't say yes or no. And the others died in jail. And what happened there? Well, there is a theory that the wheat was infected by a fungus called ergot. And in ergot is LSD. So all of these people gathered their wheat in, ground their harvest, put it into loaves and cakes and whatnot, and basically ate LSD. And then all of the villagers were having seizures and strange visions, and they just attributed it to 200 random people who were probably also having hallucinogenic moments and seizures, but they were the unlucky ones. So if you ever see this in a wheat plant, do not eat it. Fortunately for us, the farmers have to take this out before it goes into our grain, but just be aware. Okay, so we talk about wheat and it goes into bread and cakes and all that kind of stuff, which you'll find out over our quiz. But what else do we use it for? Well, we have thatching, so building materials, even particle board ends up with wheat in it. I didn't know that. It's amazing what you find out when you have to do a talk, isn't it? Play-Doh. It's basically just flour, colour, and water. Golf tees. Someone is making golf tees out of wheat. Who knew? Paper. Makes a little bit more sense. Glue. I don't know if you've done paper mache and mixed flour and water together to make a glue. Well, you can make industrial glue out of wheat as well. And my favorite, slug control. Now in South America, they take the grains of wheat, they chop them up, and they spread them on the ground. The slugs eat them so fast that they can't digest them. They swell up and explode. Bit of an extreme way of controlling slugs, but apparently it works. So that's wheat through the ages. But what about where it's going now? How do we know? Well, I don't know. I'm not a clairvoyant. I know where I'm trying to get it, and that's having it as more carbon neutral, easier to grow, higher yields, but still on the same amount of land, or less if we can. But other people have theorized that this is what it's going to look like. Now, I'm slightly concerned if a wheat ear turns into this, because it's going to need a tree trunk to hold it up. But in the early 1900s, this was thought of where it was going to be. We also have the possibility of indoor growing of wheat, which may be a possibility, maybe not. If you're here tomorrow, you might hear one of my colleagues talk about whether this will happen or not. And maybe this is the way that wheat is going to go. So that's all I have to say. I've got a few minutes for some questions if you want. So thank you very much for listening. And yeah, thanks.